Oh, hello. Today I'm going to make a video about a very misleading keyword in C++, which is inline. Okay. What does this keyword means in C++? Okay. So first I'm going to show you with the gobble. So we have a function foo. I'm going to return something. Okay. Return, for example, return. I don't like to use end. I love to use CSS with std size here, right? So return 5. Okay. No except. So we can see the compiler generates some assembly here. What happens if I mark this function as inline? You can see the assembly. There's no assembly to display. You might say, why? Why adding inline? The function won't emit anymore. Okay. This is that you need to remember. Inline is a very important keyword when if you don't want that code in your binary, because if you don't mark a function as inline, the function will be exported to the binary. Even you're not using that function, even I'm just doing something else. For example, I'm doing something else like bar, no except. Okay, I'm not using that function. I'm returning to 10, right? And then I call int main. Then I return. I'm using whatever. Let's use stdio print zu bar. So we have another function that looks like this, and we can see even we are not using this full function, the function will still get generated. You might say it's because I'm not enable optimization. What happens if I enable all fast optimizations here? We can see even the 10 we write here that gets inline here, the function body is still get generated. The way to solve that problem is that we mark this function as inline and the function disappears, right? Okay. So inline, a very important reason to use inline is that if you're not marking inline, you will have that code in your binary. Because if the function is not inline, the compiler will think you want to emit that function to the binary, then that's what that means basically. What happens if I write something else like a context per, for example? Context per indicates inline, which means if I write context per, I do not need to write inline anymore. Now, so you might say, what does that mean, right? What does that mean when I write something like this? And well, the actual meaning of inline is that inline means something called ODI violation. So I have a function called ALCC. I want to just, for example, I have this inline function, right? Then another function I want to compare to which is also inline, which is also called foo. We normally now have two functions in two translation units that emits they are different, right? Just although they are the same function, one is return 6, another one is return 20, right? So when that code compiled, for example, okay, if I compile that, then what can do is that we don't know what the assembly is because we link them together, right? But we want to see assembly. What we can do is that using a tool called GTIRB, we emit that to the assembly. And we use this GTIRB preprinter. Okay. Then we see the assembly here. So we can see here the function calls z3for v, and if we look at the function, it returns 20. Can we see that function returns 10 here? No, the function does not exist anymore. Only the function returns 20 will emit to the binary. Since I'm not enable optimization, that's why you'll see something like this. But which means if you have two function that is in the same is in the executable with the same name in different translation unit, what happens is that the compiler will, no, the linker will discard one of them. So if you have the same function with different in a different translation unit, the compiler will discard the symbol, which means inline has nothing to do with what you understand, what I'm expanding something like that. It has nothing to do with that. Inline means, Mr. Linker, please discard duplicate symbols. Okay. Now you might say, the code is very wrong, right? Because if I have another function, why I cannot return Q here? Whatever. What the fuck? Not QA. Okay, sorry. So you might say I have a function called foo, right? But it returns 20. In another translation unit, the function returns 6. Okay, it's not a foo bar. What we should do is call foo plus bar. Okay, something I did wrong here. It doesn't matter. It's just wrong, right? It's completely wrong, right? It's wrong because in the same one translation unit, if it returns something, do this thing. In another translation unit, it do another thing. But the linker discard one of them. What happens is that then you will have a very serious problem, which is called ODR violation. ODR violation is an undefined behavior. Okay, ODR violation is undefined behavior. Okay, inline function, if you write inline, which means the compiler will duplicate symbols, but even they're different, the compiler will still duplicate they discard symbols, whatever. They don't care about what the function inside it. Then you think about the functions, since the functions are different, you get a crash, for example, right? Can we just emulate some kind of crash here? For example, if I have an array here, I think I can emulate a kind of crash. QA, Q, not similar. For example, have a pointer. I give a pointer, pass a pointer here, a pointer 4, right, for example. Then, for example, I have another function. What I did is I pass an array here, but my array has 10 here. I have 10 buffer size, and the pass full here, right? Probably going to pass 10. Okay, let's pass 10. Another translation unit, I also pass that pointer, right? Let's just assume that case, okay? I'll do something like this. I call that function. Okay, just call that buffer. Okay, whatever. I call this buffer. And what in another translation unit, what I did is that install buffer, and then call buffer here. Okay. Now I'm going to do is that I'm going to write this buffer as full, for example. Let's just assume that. Okay. So if we compare it with sanitizers, something like that, probably we are not going to get a crash. So let's see. Probably we're going to get a crash or undefined behavior or something like that. I don't know whether. We're not crashing, right? Because the reason it's not crashing is because now only this function is discard. I think what's happening right now. Okay, this foo does not exist anymore, right? The actual foo is full, right? What if we do the opposite thing? We put here as full. With another translation unit, we get awesome. work here we do 4, but in another translation unit we get 10, for example, right? Because we think they are different functions. For example, let's just assume that case. We probably get a crash here, right? So the function inline means discard duplicate symbols. Okay, which means if the functions are defined exactly the same, the linker will discard any of them. This is extremely useful and important if you're writing the header-only library. You basically have to mark all your functions as inline and protect with the namespace, because namespace is a way to prevent a lot of ODR violations here. But it's just not a very good way to just fully detect an ODR violation. So we can see that inline has nothing to do with what we normally understand in C++, right? Now you might say, what happens if I enable something like optimizations? Okay. Still get a crash, right? Still get a crash, and let's just ignore that part. Let's see what the assembly generates. Okay, we don't care about what the stuff here is. We just only care about what the assembly each transition unit generates. We can see, we're probably not optimized. We can see, it's not A. Is that ALS? Yeah, it should be ALS, right? Oh, if we just put here, we don't actually need that. Right? You can see it just calls by. It doesn't matter. It does not matter what our function is, because that function does not exist anymore. But if we're not marking this function as inline, for example, we're not marking this function as inline, we mark it as something else. Okay, then this function will be emitted to binary. Even we're not using that function, right? When the function is inline, why the function still gets into binary? What probably we can do is that we can do something else. We're not calling the function, we just do int 0, return 0, okay? We think the compiler, what the compiler should do is that it does not care about the function is, and it should, the full function should not exist in our binary anymore, right? Let's see what's happening here. So, yeah, we can see even when I'm not using that full function, the function, it still emits into the binary, right? We see the function here. If you don't believe the function here, we can actually use the C++ flag here, right? C++ filter here. We can see this is a full function, but we don't use that function, right? We don't use that function, why it emits to the binary? It doesn't make any sense, right? Which means if we're not using inline function, we are not going to bloat our binary. Okay, inline is extremely important, because if we don't write function as inline, it emits to the binary. Okay, now we can see that inline function does not exist anymore. So there's another function, okay, called static. Static inline and static are exactly the same. Please don't be foolish. It does not matter, okay? What if happens I'm writing something like static here? Okay, the function does not exist too, and even when not enable optimization, the function still won't exist here. Okay, the function won't exist at all. It doesn't matter. It just doesn't matter whether the function exists anymore. So you might say, what's the difference between inline and static? So we just write 3 functions. Okay, one has CP, another NP. Okay, we just do something like this. NP, return P. Okay, every function we do is some functions like this. Then we have another function called just normal function. Okay. Normal function, okay, is just like extern function. You can just treat that way, okay? Which means if you're not marking extern, it means I'm going to export that function. I'm going to write another function called bool, okay, bar whatever, just whatever, it doesn't matter, right? So these four functions are exactly the same, but we're going to see what the sum rate generates. Okay, so here we can see the function bar and bars, they're exactly the same, nothing different, but they emit to the binary. The full and bar are not emitted to the binary because they are not inline. They are either inline or static function. Static means if I have two functions in different translation unit, it duplicates. Inline means discard all the symbols, discard duplicate symbols. They're extremely different. Okay. So if I enable optimizations, I probably should enable all the exception handling nonsense, because C process exception is terribly nonsense. It just affects how I read the assembly. Asynchronous unwind tables. Please just never use exceptions. Right? Asynchronous. I have no exceptions table. Okay, so what we are seeing is that here, even with the highest optimization level, the bars and bar function will still exist in the binary, but bar and bar not exist in the binary. Okay. So which means inline plays a huge role for dead code elimination. Okay. Now, so what's the lesson we need to learn here is that we need to basically mark every function as inline. If you're not supposed to export it, we should just mark something inline. A simple rule is that every function should be exactly one external static or inline or whatever, inline concept or whatever. You can just write concept, right? It doesn't matter. But so which means every function should be marked exactly one inline external of external. External means export that function. For example, this intermain function is actually external function. It's nothing different here. Okay. If you're not marking anything, then it's an external function. External static inline. Okay. Just like we write virtual override or final, you should just write external static or inline. Okay. It has nothing to do with optimization. Please don't fool yourself. It has nothing to do with optimization. The only thing it plays is to tell the compiler, please do not emit dead code. Okay, please don't emit dead code in my binary. You can even write things like this, right? I'm just doing something like recursive function, right? We can see even recursive function should be inline too, because if we don't write back to the inline, then it emits to the binary, it emits itself. But if we're writing inline, it won't emit to itself, right? So inline has plays a role here. Okay, so inline means ODR violation and means duplicate symbols. Okay. Now, even the same function, you can see you just don't see as inline. If we run back inline in the main, what happened here? Let's say inline we cannot define main as to be inline. The reason we cannot do that is the standard requires it. Because if you think even marking that as inline, which means your main function does not exist anymore, right? It eliminates, it can eliminate it. It does not exist anymore. That is clearly wrong. That's what we want, is that we don't care about that, right? So if we destroy that, they emit to the binary. And even when we call that full function, we still won't see that function too. Okay, we won't see it. Inline controls that behavior, very important. Now, there's a very important thing I want to mention here, is that if you have two functions, for example, we have a function in the A.C, we have this bow function. Okay? Every function, we just don't care about it. It don't matter. We have the bow function. We have another bow function. Okay. in the P should be exactly the same. No except. Okay. What happens if we try to clan plus B? Okay, let's use C. Okay, that's C dot A dot CC dot CC. To operate the function, yeah, the two functions is not the same, right? That's why we don't get a collision because of the mangling in C++ place. But what if we change that behavior to exactly the same? Then what we do is A dot C B dot C. You can see we get multiple definition error here because they both export. You can think they both export to the binary, but they're same function, right? You cannot have multiple definitions with that. And if even we optimize that code, we still get that error. Probably we could not enable the error if we have LTO. I don't know what LTO will do something. Yeah, even with LTO, it's still duplicated. So we cannot do this at all. Okay, if we have the same function in two different transition units, that's going to have the problem. You might say, why that is a problem, which is related to your header file in C++. For example, if I have a header file, we have a function. You think you are defining some max function, whatever. You define your max function. I don't like to use the keyword int at all. I think keyword is a mistake. We use size d. Okay. Now, I just use full. Okay, don't use max. Okay. Now you think you're providing some library functionalities that can be used. Let's just add b plus 1, b plus 2 here. Okay. If we use C++ 23, we should write 2 SE. Okay. 2 SE, right? Now I have the full function. I have the function. I include that h header. The header. And I have another binary. We also include that function. We just include that binary, okay. We include that. We don't care about what the content is. We just do is that we include that header file. Okay, it should be header.h. Okay. Okay. So what we are trying to do is that we try to use that library. You think you're providing some header-only library, right? Something like that. But now you're gonna see. Oh, we cannot do this because it's C++ 23 to be okay. Invalid. Probably we can use G++ because probably clan does not. This clan version is old. It does not support that. Right. I'm able to find. I quite don't know. Okay. Probably we shouldn't do this. Okay. Let. Probably it's in other header files. Let's just use 2u, okay? It doesn't matter. B dot A, no, A dot CC, then we call A. We can see we get real errors here because you think it's a header-only library. We think it's a header-only library, but what's happening here is that function will emit to the binary, right? Because I think the two functions now emit to the binary. So you have the same function emits to the binary, and then you get a duplication here, multiple definition error. To change that problem, what you're going to do is that you write concept term. It's one already inline. Okay. If you don't think it's enough, if you're not confident enough, you just write inline that concept. Then the problem will disappear. Okay. Now, UMS C++ now also has the new functionality, which is called in C++ 17. It's not actually very new, but it's that now you have these new fancy inline variable functions. Okay, what does that mean? Okay. Right? Oh, we shouldn't write full bar. Okay, call the variable bar. We get a multiple definition errors here. What we can do is that if you want to do that, then you should write inline. Telling the compiler, discard duplicate symbols. Okay, all you can do is writing extern, context extern, because context extern indicates inline. It also works. Okay, that's all about the entire video, and please never think about inline as some kind of, yes, we have multiple definition error even with LTO, right? So please never think something like this, okay? If you're not confident in one, you just write inline. You always write inline. Okay? That's it, right? So yeah, that's all about the entire video, and I hope you enjoyed the video. And yeah, please never think that way, because a lot of people complaining about whatever nonsense. They don't even understand what inline means, and they complain bullshit. That's exactly the video I want to make here. It has nothing to do with what you're understanding. It has what it has to do with dead code elimination stuff. Okay, and tell something with a linker. It basically tells something with a linker. You can just think of it. It has nothing to do with the compiler. It does not tell to compiler. It tells to linker. Okay, that's what inline means. It means discard symbol. Okay, please discard symbols here. Yeah, it does not affect whether how the compiler optimizes code. It doesn't. Okay, but if you're not writing inline, your code will be slower, because now you have duplicate symbols in your binary. It blows your binary size. Okay, so be careful when you're not writing any non-inline function. If you try to export that function, you have to be very careful, because if you export too much functions, for example, if I write too many functions here, okay, now I have another function. Okay, I have another function. What I want to do is try to export these two functions into my binary. Right? I want to export them and use that in another binary, in another translation unit, in another translation unit, XNC whatever, external whatever. If you're in that kind of situation that you do this, okay, then even you're just calling this, even you are just calling foo, bar will still be in your binary, okay? Okay, which is very important, which means the linker, okay, when they link them together, they don't eliminate dead code, okay? They don't care about dead code. Okay? It doesn't eliminate dead code here. And if you try to call both of them, you try to call just one single function inside this translation unit, the entire translation unit will be loading in your binary. Okay. What if I just keep writing this function? I just write another function. I just write foo1, foo2, foo3. Now you can think of a lot of even the Linux kernel, I think, has a problem here. Even glibc has a problem, which means even I'm not just using the foo function here. All these functions will export into my binary. Even I'm not using those functions. Even I'm not using bus. I'm just using false 4. It will all emitted to the binary, okay? Which now, I think I can just show an example here with different libc implementation. I want to show is that something which is a new libc, not new lib, it's a new, quite new, a libc that written quite new, which is called mlibc, okay? I want to use that as example. Okay, let's just use stdio or whatever as an example. Okay, I believe this is quite popular for people who they're writing their own operating system. Okay, which is they cannot use master, they can use glibc, but they're using this mlibc stuff. Okay, now first thing is the last time I said you're not marking this function as no except you get a binary below. And second is that we call this final. Let's just see what the final is defined here. even I'm just calling this final, okay, I'm just calling this final. What's happening here is that they will still get emitted into my binary. Even I just call that final. All the fopen, fflush, and flush unlock of ftail, they were all emitted into my binary. Even I'm not using those functions. Since you write the code this way, they were all emitted in my binary. And they put this inline namespace as the none. Just this is basically unnamed namespace stuff. They all emit into a binary, even I'm not using those functions. Even I just use std out, std in and std error will still emit into my binary. Okay, I'm just using fopen, whatever function I use, they are in my binary. That's why a typical static link mlibc executable is just 100, 200, even larger, 200 kilobytes larger than what muscle libc does. Okay, we'll see what the muscle libc did, okay, or new lib did. We can see they write every function as a single translation unit. Okay, the reason they do this is because if they just use their functions, they will only emit to that function they use. They will not emit the function they don't use. Okay, that's extremely important if you care about binary size. The same thing is also true with new lib. Okay, which is very popular in the embedded systems or in bare metal systems. If you can see they write every functions with one function, right? Sometimes they write two. For example, this is not good. But basically what they're doing is they try to minimize that translation, because yeah, it takes human time to just separate them to every functions here. And this is basically doing a lot of stuff, basically same stuff here. But I think Master libc did the best job here. Is that they put every functions as a single function, which means if I just use fflush, I won't introduce any other stuff in my binary. Okay. Now the same thing if you think about glibc also just do a lot of things. They will emit to your binary. They have a lot of functions in the same function, some functions that can emit to your binary, which is quite hell. So in fact, we have living a very dilemma situation is that if you are just trying to separate them into different translation units, you're going to compile all of them, then you're going to compile even the same headers with the same time. They probably going to be very slow for compilation. But on the other side, if you're not doing that, you're going to get that code in your binary, okay, which is you have no way to solve it. Now you might say LTO, but LTO won't eliminate the code that does not have LTO information. Okay, I think there's some linker flags like f data sections, whatever f function sections. They just to do that, but in general, it's not good. Okay, it's not good at all. So the good side with C++20 module, but I think the module is a very terrible situation. Is that theoretically, okay, you can do is that you can mark all the functions as inline into the modules and export them. Then you won't get that bloat. But the problem is that now you might emit a very large IR into the compiler. Then the compiler probably can compile very slow with it. So they are all trade-offs, but C++20 modules give you a fair trade-off for those things, which is basically you can now write a lot of inline functions without worrying about a lot of problems, even templates within the modules. Okay, that's all about the entire video. And I hope you can understand what inline means. It has nothing to do with what you're understanding. Even, okay, I think this is very quite interesting stuff with that stuff. Is that what you actually do is that you write GNU no inline. Inline. You can actually do this, which is inline no inline. Okay. You might say, what's that mean? Right? This means expanding. This means discarding. Okay, they mean completely different things. Okay, you can write something like hot or whatever.
But the complete different things. Please don't be foolish by yourself. For example, you can even do the opposite thing, that you have the non-inline function, but here you call it a false inline, right? Now, false inline, you can see the function still emits to the binary, okay? The function still emits to the binary. That's why I'm saying basically inline, the false inline sub is completely useless, right? It's completely useless. It has nothing to do with what the compiler is doing. There's a use for false inline, what I think about, okay? It's actually not quite related to the optimization. It's to probably improve compilation speed, to reduce the depth of the AST, the abstract syntax tree, because if you inline to the depth of the inline tree is too deep, you get the compilation might get extremely slow by just keep trying inline that function, whatever. Forcing gives a hint to tell the compiler, you just do inline, you don't care about other things. But in general, it's not a good option at all. Please don't use it. Okay, that's about whole entire video. I think you should understand what things going on here. You can even have inline, no inline, false inline, whatever. You can put them all together. Inline, no inline, whatever, no inline, whatever, something like that. It doesn't matter. Okay, that's it. Thank you for watching the video.